finish with the chapter 14 of our marine electricity handbook, marine generators. And today we are going to finish with the troubleshoot on generators. The troubleshoot on generators is basically the same, doesn't matter the manufacturer of the generator. If the generator is Kohler or Westerbeek or Onan or Caterpillar or whatever, the procedure is the same to solve the problems, and the procedure is the same to read the codes and clean the codes. If the generator is digital, of course, or if the generator is analog. I am going to explain the general procedure to solve electrical and mechanical problems on generators. We are going to follow the most common type of codes related with the problems on generators. The first code is LF. LF is a low frequency. Low frequency is basically a fuel restriction or air restriction. Fuel restriction is basically a problem with the fuel filter, fuel contaminated, or fuel lines clogged. Air restriction is basically a problem with the air filter or problem with the insulation of the sun shield of the generator. Those issues produce basically low engine RPMs. Low engine RPMs are related with low frequency. Other common problem is HF. HF is high frequency. High frequency normally is an issue on the governor of the fuel injection pump or the governor of the carburetor if the generator is gasoline. A mechanical problem on the governor produces overspeed or high RPM. This is a typical fuel injection pump, rotary pump, and this is the governor and this is the fuel injection pump. A mechanical problem on the governor produces that the handle stay higher or lower and the RPMs increase or decrease. Mechanical problems on the governor produce normally high frequency or overspeed. Other common problem is overvoltage or undervoltage. If the overvoltage or undervoltage is only 10% higher or 10% lower, both of them, you can calibrate both of them at the voltage regulator. Right now I am going to explain the procedure. Only if the increment is no more than 10%. For example, if the output voltage is not 120, is 135, that excess of voltage can be reduced if you calibrate at the voltage regulator the spot voltage. The voltage regulator, this is a typical voltage regulator. All the voltage regulator, they have three spots that you can calibrate with a small flat screwdriver. Those spots, one spot is for voltage, other spot is for stabilization, and other spot is for gain. If you have a higher output voltage, for example 130 volts, you can calibrate with this spot. You can reduce the voltage, of course, with the engine running and the voltmeter connected in the output breaker of the generator. You can calibrate the output voltage. Or if the output voltage is a little lower, no more than 10%, you can calibrate with this spot, high or low voltage. Right now I am going to explain the other two spots, stabilization and gain. Okay, if the output voltage is high output voltage, over voltage, high output voltage, more than 10%, for example, the output voltage is 150 volts, not 120, 150 or 160. What happens in that case? If the output voltage is high, more than 10%, you have two possibilities. One possibility is an open neutral. Other possibility is a bad winding. Probably the winding is in short or the winding is open. How can I check the condition of the winding? With the megometer. I explained in the episode number 4 the procedure to check the condition of the winding with the megometer. Other possibility is UV under voltage, but more than 10%. For example, the output voltage is 80 volts or 70 volts. In that case, probably you have a short to ground on the stator or on the rotor. Both of them can be checked with the megometer. I explained in the other episode the procedure to check with the megger if the winding on the rotor or on the stator is in bad condition. This is over voltage and under voltage. Okay, other typical problem is output voltage fluctuating. The output voltage is not stable, it's increasing and decreasing. Output voltage fluctuating. That problem can be solved on the voltage regulator in the spot stabilization. Normally the second spot is stabilization. If you adjust that spot with the generator running, producing power, you can stabilize the output voltage. The spot stabilization is used to correct voltage fluctuation. The last one is the gain. The gain is basically the time that the generator needs to recover the RPMs when the load is applied. If you remember, when you apply load, the generator, you start the generator with all the breakers off. Immediately you start to apply load, other load, and finally at the end you apply the heavy loads, air conditioning equipment or pumps. When you apply the heavy loads, you hear that the generator decreases the RPMs but immediately recover the RPMs. In some cases, when you apply heavy loads, the generator decreases the RPMs and spend 2 more time to recover the RPMs. You need, in that case, adjust with this spot the gain. You move it a little and you apply the load again and you check if the generator responds immediately. If you need a little more calibration, you move it a little more the spot, you apply the load again and you verify. In other words, the gain is the spot used to calibrate the response of the generator when the load is applied. Okay, we are going to review. The first spot is for voltage to calibrate high or low output voltage, no more than 10%. The second one is stabilization to verify fluctuation in the output. And the third one is the gain. That spot is used to calibrate the response of the engine when the load is applied. Other typical problem is a slow response when heavy load is applied. That problem can be solved on the gain, on the spot gain. The last one is the generator is running, but no output power, no produced power. There are different possibilities. The most common possibility is the breaker on the generator is bad. You need to verify the voltage before at the input of the breaker. If the voltage at the input of the breaker is good and in the output nothing, probably the breaker is broken. Other possibility is no excitation. Remember, we have two types of generators, armature type or generator type. The armature type is the excitation is produced with brushes, and that excitation is coming from the ignition switch. You need to verify if the brushes are in good condition and if the power coming from the ignition switch is good power. The other type of generator is with a bridge of diodes. Probably the bridge of diodes is damaged and no DC current, no AC current is produced. In that case, you need to replace the bridge of diodes. Other possibility is the fuses on the control box are broken. Normally, the majority of the generator, they have 2 or 3 fuses, F1, F2, or F3. You need to check the fuses. Other possibility is an open or short on the winding of the stator and the winding of the rotor. This is basically a procedure that you can verify with the megometer. Okay, other possibility is that the generator is cranking, crank, but no start. When the engine is cranking but no start, normally this is a problem of fuel, but in some cases it's an electric problem. You need to isolate the problem. You need to identify if the problem is fuel or if the problem is electrical. And you need to check my engine is gasoline or my engine is diesel. The first step is isolate the electrical problem. Suppose that the generator is gasoline. I need to know if it's gasoline. I use That proof, to verify, I introduce this one on the spark plug and the cable here. And I crank and I verify in each cylinder if I have a spark. If I don't have a spark, I need to follow the procedure that I explained in our marine gasoline book. The procedure on the coil, the procedure on the distributor. You need to follow all of those steps in order to verify why I don't have a spark on the spark plug. For that reason, the engine no start. This is for gasoline. For diesel, in diesel you have two possibilities. My diesel engine is mechanical fuel injection or is electronic fuel injection. Okay, if my diesel engine is a mechanical fuel injection, probably the problem is at the input of the fuel injection pump, mechanical fuel injection pump. I have an example here, and on the screen you have another example. This is a rotary mechanical fuel injection pump. Rotary, because this is the input, the output per each cylinder, mechanical fuel injection pump. But all the pumps at the input, they have one solenoid. Other pumps have a solenoid similar to this one, or the solenoid that you have on the screen right now. The solenoid have a positive and negative, exactly the same in this pump. Positive and negative in order to open or close the solenoid and the fuel enter or not. This is the most critical solenoid in a mechanical fuel injected diesel engine. The fuel injection pump on the governor, they have a solenoid, and the solenoid positive and negative is activated where? From the ignition switch. On the ignition switch, in the ignition position, the purple color goes into the ignition bus bar, and from the ignition bus bar, other cable enter in the fuel injection pump, and immediately you open the ignition switch, the fuel injection pump, the solenoid open, and the fuel enter, and the motor start. This is the element that normally produce that problem. Crank, but no start. 100% sure that no power is coming into the fuel injection pump. How can you solve that? With an alligator cable, you replace that one, the positive, with a positive directly from the battery here. You connect temporary one cable over there. You try to start the engine, and the engine starts immediately. It's because this cable is not with power. You need to follow the harness and verify why power is not coming in this point. When you put the power directly here, the solenoid open and the fuel enter. This is the most common problem in mechanical fuel injection system. If the diesel engine of the generator is electronic fuel injection, you need to verify in the computer what is the pin on the computer that you have on the screen right now. You need to verify in the manual what is the pin for the fuel injection, for the solenoid of the fuel injection pump. Is the pin 17, and you check the pin 17 with the voltmeter, and you verify if the voltage is coming out. Normally the voltage is around 4.7 volts, 5 volts. This is other procedure that you found it in our marine diesel engines book. Okay, this is the situation when the engine crank, but no start. Electrical problem or fuel problem. Okay, now we are going to analyze the fuel problem. If my generator is gasoline, the only that you need to verify is the transfer pump. The transfer pump is running. You disconnect the output of the transfer pump. You have the transfer pump on the screen right now, and this is the output of the transfer pump, and this is the input. And from the input, the fuel is coming from the fuel tank. That's too simple. You need to activate with a couple of alligator cables the pump directly in the positive and the negative, and verify if the pump is pumping fuel. Okay, if the pump is pumping fuel, you need to go into the carburetor. And normally in the carburetor, you have an idle solenoid. It's similar to the solenoid on the fuel injection pump on diesel. This solenoid open and close and allow that the fuel enter in the carburetor or in the throttle body. If the solenoid is closed, the fuel never enter. If the solenoid is open, the fuel enter. This is exactly the same like in diesel. You have an idle solenoid. In each manufacturer have a different name for this solenoid. Idle solenoid or low RPM solenoid or on and off solenoid is exactly the same. It's basically two cables positive and negative. The negative is coming from the negative bus bar, the positive from the ignition switch in order to open or close the solenoid and the fuel enter. This is for carburetor or throttle body gasoline engines. For diesel is with the solenoid, with the electrical solenoid. Power on the solenoid, no power on the solenoid, the engine start or the engine not start. Okay, this is the solution. Okay, the fuel is coming in, no fuel coming in gasoline. You solved the problem. Probably the fuel filter is clogged or not clogged. Normally, when I have problems like this, that the engine crank but not start, I visit the boat with two portable tanks and with two priming pumps, ball pumps, and I connect my portable tank directly to the generator, and I start the generator with my fuel. If the generator starts immediately with my fuel, it's because the problem is in the fuel system of the boat, and you need to follow the fuel lines on the boat and verify where is clogged the system. Doesn't matter if it's diesel or gasoline. Okay, now we are going to return to the diesel engine. The problem is fuel. The fuel is not coming in. You need to verify the primary filter. You remember in a previous episode, the Raker-Parker filter. Verify if the fuel is passing the filter, if the filter is clean. If not, you need to do the service on the filter. Check the episode on the diesel book. You clean the filter, you replace the O-rings, the ball, or the service on the Raker-Parker filter. Okay, I have fuel on the Raker-Parker filter, no water. And let me check the secondary filter. The secondary filter that you have in the picture right now is good. The fuel enters in the filter and the fuel goes out to the filter. The fuel is good. And now let me verify if the fuel enters in the fuel injection pump. Oh yeah, I have fuel in the fuel injection pump. Then the problem is the solenoid. The solenoid open or not open, and that's the problem. All right? Always, when you have a problem that the engine crank but not start, you need to separate. Is electrical or is mechanical? If it's mechanical, normally is no fuel. If it's electrical, you need to verify. Is gasoline? Spark? No spark. Is diesel? Power on the solenoid of the fuel injection pump or no power on the solenoid? If the system is mechanical. If the system is electronic with computer, you need to verify on the computer what pin is the pin designated for the fuel injection pump and what is the pin designated for the injectors, and verify if you have power on the injectors and if you have power on the solenoid of the fuel injection pump. If the system is with computer, remember, go into the computer like the picture right now. Check what is the pin on the computer designated for the injectors and what is the pin designated for the fuel injection pump. Both pins have a different voltage. Probably normally the voltage for the solenoid is around 12 volts, and the voltage for the injectors is in between 4.5 volts and 5.2 volts DC. DC, my friends. For that reason, you need to use all the time this tool. I love it, this tool, because you put this one, the negative, in any part of the negative bus bar, and because this is fine, this is sharp, you punch the cable that you need to verify if you have power, and the light indicate to yours if you have power on that cable. This is excellent. I want to know in this particular case if power is coming into the solenoid. I touch the positive, I crank, no light here, no power is coming in. This is only for DC. I recommend when you test DC, use the test probe. Okay, that's the procedure to check when the engine is cranking but not start. Other common problems are those codes. That code is AF, auxiliary fault. AF. This is the digital computer of a color generator, and those are the codes more commonly used in marine generators. And I am solving each code. We solved high frequency, low frequency, high voltage, low voltage, over voltage, and now we are going to solve other mechanical codes. Other common code is AF, auxiliary fault. If you have that code flashing on the display of the computer, that code, auxiliary fault, indicate that the problem is on the harness outside of the generator. It's not on the generator. It's outside of the generator. It's in between the generator and the remote panel. You have a problem in the harness that you have on the screen or on the remote panel. You need to identify where is the interruption. Normally it's an open circuit. It's a cable that is cut or is interrupted, or loose terminals. In some cases, this is the problem. This is auxiliary fault. It's a problem outside of the generator. Other common problem is CC, crank cycle. CC. This is, in my opinion, one of the most critical codes. When the customer calls to me and says, Mr. Lopez, I have a code CC. The battery is new one. The cables, the terminals, everything is perfect. And CC, What is the meaning of that? CC is indicating that the cranking cycle, in order to start the engine, is not complete. The cranking cycle stops suddenly. The motor, normally, when that code is on, is because when you try to start the generator, run the generator, you hear that the generator click and stop, click and stop. Normally, what is the procedure to solve that code? First of all, check the condition of the battery. How? With the load tester. Disconnect the terminals of the battery and connect the load tester that you have on the screen right now. Connect the load tester and verify. The needle of the load tester goes into the red area. Immediately you apply the load, the battery is out. The needle stays in the yellow area, it's because the battery needs charge. The needle goes to the green area, the battery is good. Simple. Use the load tester. Alright. The battery is good. Check that the power entering here on the solenoid of the start motor is good. Verify that you have good power here and the cable is tied properly. Verify that the crank relay is working good. When you activate ignition, the signal is on and the power passes over there into the motor. If the power is good, you can check that procedure in the chapter 6, charging system. I explain in details that procedure. Alright. The battery is good, the cables are good, the solenoid is good, the relay is good. Now, the possibility is salt water enter in the combustion chamber. Oh la la. Yes, this is a common problem. What is the meaning of that? That in some cylinders is salt water. How can you verify that? If the engine is gasoline, or the engine of the generator is gasoline, remove the spark plugs and verify which spark plug have water. Normally, if the cylinder is full of water, immediately you remove the spark plug, the water is coming out. Or you see corrosion on the spark plug. It's water. If the engine is diesel, exactly the same. You need remove the injectors. Immediately you remove the injector, you see the water coming out, or you see the injector completely corroded. What is the indication over there? That you have salt water over there. What is the next step? If you have the stethoscope, if you have the boroscope, you remember the camera, the small camera, try to use the camera, introduce the camera on the hole, and you can verify if you have water or corrosion in the area of the cylinder. The next step is try to move the crankshaft of the engine with your hand. Put a socket on the harmonic balancer and with a wrench and a pipe, you can move it. If the crankshaft is impossible, is completely stuck, it's because you have salt water on the engine. And what is the solution? Rebuild the engine. This is an expensive solution, and you need to explain to the customer. The generator, the engine right now have water in the cylinder 1 or in the cylinder 6 or in 2 cylinders. And what is the solution? we need remove the engine, remove the head, verify where is the water on the cylinder, like in the picture that you have right now. This is water in one cylinder, and the solution is normally rebuild the engine. Can you repair partially only that cylinder? Yes, it's possible. In my diesel class, I explained that procedure, how to hunt the cylinders, replace the ring, the pistons. This is possible. This is one of the projects in our diesel class. Okay, if you have water on the cylinder, finito. The problem is finished. This is other common problem. Okay, this is CC crank cycle. Other is low battery. Okay, this is simple. With the load tester, you check the condition of the batteries and you verify if the battery is okay. Be careful, because in some cases the battery is good. The problem is the alternator of the generator. The alternator don't send the charge properly. You need to verify in the output of the alternator when the engine running, if the alternator produce more than 13.2 volts DC. All right. The next one is a.c.r, low coolant level. Okay, my friends. This is the next explanation is a short explanation, but I recommend that visit the videos, the episode on my diesel book, because on those episodes I explain in details that situation. When you have a problem of temperature in a diesel engine or gas engine, marine engine, you need to isolate the problem. You need to isolate if the problem is on the coolant system or if the problem is on the salt water system. If the problem is on the salt water system, you need it verify from the C-cock, from the valve, from the strainer, and the raw water pump, and verify if the raw water is passing all of these parts and entering in the heat exchanger. This is the first step. Verify if the problem is on the salt water. Okay, let me check. Go into the C-cock, open and close the C-cock. Verify that the water is coming out. Next, pass to the C strainer. Verify that the strainer is clean. No bubbles on the strainer when the water is passing. Okay, the strainer is good. You can open the strainer a little, because remember in the previous episode I explained the strainer and the raw water pump should be located below the water line. What is the meaning of that? Those elements shall be full of water all the time. You open the C strainer, you verify that the water is coming out, you close immediately, you tight, and you continue into the raw water pump that you have on the screen right now. And on the raw water pump, you disconnect the output hose of the raw water pump, this pump. On the raw water pump, you have one input and one output. You disconnect the hose here and you verify with the engine cranking that the water is coming out. All right, I have water here. Let me go into the heat exchanger and I check the input of the heat exchanger. I have water here. I disconnect the output of the heat exchanger. No water coming out. The heat exchanger is clogged. I need to remove the heat exchanger and do the service on the heat exchanger. Check my episode related with heat exchanger in the diesel book or gasoline book. All right, you do the service on the heat exchanger. You clean the heat exchanger, and right now the water is coming out. Okay, that was the problem. The problem was on the salt water. The other possibility is that the problem is not on the salt water circuit, it's on the coolant circuit. In the coolant circuit, I need to verify if my coolant pump or circulating pump or freshwater pump is good. I need to verify that the hole that all the coolant pump have in the bottom is not leaking. You need to verify that the coolant pump doesn't have play. If you found a little play on the pulley, it's because the shaft is broken and the coolant pump is out. You need to verify also if the thermostat housing is good. If the thermostat internally is opening and closed properly. Check the videos about the thermostat housing in my diesel book. The procedure to verify if the thermostat open or close according with the temperature. Check the expansion tank cap or radiator cap is exactly the same. Verify that the cap open and close is exactly the same like the thermostat. Check the reservoir of the coolant. the reservoir that you have on the screen right now, and verify that the water is in the limit. Normally when the engine is off, low temperature, the coolant, the level of coolant should be located in the bottom mark. When the engine is too hot, the level of the coolant should be in the second mark, in the top mark. If this is okay, it's because the coolant system is working properly. But normally the problem related with coolant is problem on the coolant pump or circulating pump, problem with the thermostat stay closed, or a problem with the radiator cap. How can you know if the problem is on the radiator cap? It's simple. When the engine is running, you found that steam, vapor going out to the radiator cap, and normally you found that the reservoir boiling with too much vapor. This is an indication, but you can go into my videos of the diesel book, and I explain in details that procedure. Alright, be careful. When you have temperature problem, you need to isolate the problem. The problem is raw water, salt water, or the problem is coolant, and the solution is different. Alright, LCL is low coolant level, is in the coolant system, and the second one, LOS, loss of coolant. Normally this one, LOS, is related with salt water. It's not related with coolant. It's related in the salt water side. Okay, those are the most common problems, the most common codes, and you need to follow those codes. Check the manual of the manufacturer all the time, because each manufacturer have a different recommendation per each code. Each manufacturer have a different options per each code. I gave to you today in this video the generic solution for any type of engine or generator. This is exactly the same for any type of engine, main engine or generator. It's exactly the same. But check the manual. Check. I have a high frequency code in my generator. Okay, I remember Mr. Lopez explained that it's possible the problem on the governor of the fuel injection pump, but let me check the manual of this manufacturer. Oh, this manufacturer said that yes, it's possible a problem on the governor, but also it's a mechanical problem, okay? You need to verify the recommendation of the manufacturer. And you follow my recommendation, follow the manual, and probably you found the problem. I say to my students normally, when you have codes, oh, I need the computer, I need to connect the computer. Before you connect the scanner, before you connect the computer, use your computer. Thank you.